Hello everyone and welcome to CCNA switching concept. So let's going to discuss about frame forwarding and frame filtering. So we have already completed the Mac learning, packaging and ARP, and we saw the labs previous classes. So you can refer this from last video, and let's we going to continue the same topic which we left from the last class. So this will be the part 2 basic switching labs. What we going to see here in part 2? In part 2 we have MAC address forwarding and filtering. We will do the lab and we will understand how the frame structure going to populated into the MAC table, and from the MAC table lookup it's going to take decision for forwarding. If required, we'll go for. Then we have to see the next topic, that is called default behavior of the switch. So for the basic switching lab, we're going to see if as soon as switch going to install into the network, so what will be the native VLAN. We are not going to configure any native VLAN. It's a by default, and we will verify what is that. That is of course VLAN1, and we can see if it is a native VLAN1, then what about a spanning tree? What is the status of the default spanning tree without any configuration, without any configuration deploy to the connected switch? And we will study about the VTP VLAN Trunking Protocol. What is the default behavior? So let's move, and we will move to the lab, and we're going to see packet forwarding, frame forwarding and filtering lab. So I'm going to access that is your packet. So here, let me show off. Here we have packetry, and I'm going to select 3 switches quickly for the lab of going for the lab of you going to see the frame forwarding and the frame filtration. So I'm going to select one switch. First switch, that's the 9060, and second switch, and this is third switch. I'm going to select only 3. I will connect with the. So I'm not going to do any configuration here. We will do our lab is going to see only the default behavior, and we will see what are the default things. Once we will connect the switch in the network, what are the default step going to run in the switch, and we will study later on. We will going to discuss each and every protocol like spinning tree protocol, VLAN trunking protocol, VTP, and other technology like trunking for native VLAN, other encapsulation behavior which is default. So we're going to see in advanced progressive lab later on. Let's understand the basic what is running on default on as soon as you will connect switch into the net. So I'm going to select a couple of desktop. That's PC1, PC0, PC1, PC. I will select 2 PC PC3, PC4 for the switch 2, and I will select one of the server for the switch 1 connect. Now select the connectivity cable. I'm going to connect with the switch 0 to PC0 and PC1. You can see the connectivity, and the one PC2 and server 0 will connect to the and switch connectivity with the PC3. I'm not going to assign any IP manually, so I'm going to configure one of the server, that's server 0, as a DSCP. So I'm going to give the name as a DSCP. This is the DSCP server, and I'm going to configure the IP address for the static, because for DSCP I need to give the static IP. For the sake of convenience to understand, this is the LAN A, so I'm going to give the switch name LAN A, LAN B, LAN C. No, this is the default behavior we're going to study, so I'm not going to configure anything as a LAN A, B, C, but I will give the one default IP in that, so that the every switch within the single LAN, because we're going to study the VLAN1 and the default behavior, so entire switch within the single LAN. So I'm not going to change anything, just I'm going to introduce one IP subnet, that is I'm selected here. Let me write so that you can refer. Default LAN, I'm taking 192.168.1 dot, and it's going to, so your gateway will be 192.168 dot. So this will be gateway, and all the server you can start your range 168.1.11. So that's the server range, and for DSCP range we'll start from 1.50.99. that's a DSCP. That's all. So let's quickly configure our DSCP for the same purpose. So this is our DSCP, and I'm going to give the first IP from the server range 192.168.11. the subnet is /24, and the default gateway we have already discussed, 192.168.1. DNS I will give 192.168.1.12. I have given the DSCP 11, and my server range from 11 to 20 throughout the same convention I'm going to follow. Next we have to enable DSCP pool, so I'm going to switch on DSCP, and I can see the pool is default given there, so I'm going to just highlight my default gateway 192.168.1.1, and DNS as we already discussed 192.168.1.12. can give the range going to start from DSCP from 50. The subnet is /24, and I'm going to take one the IP. That's all. For TFTP I'm just going to assign 92.13, the same series I'm going to follow. .11 for DSCP, .12 for DNS, .13 for TFTP, and WLC I'm going to give the 8 dot. Last IP I will give 19, or you can say 20. Now after this I have to save this because this is no need to add because it's already default one. So I'm going to want to add in one more subnet. We will later on see. We're going to create one more VLAN apart from VLAN one. Today we're going to see warning and one default behavior of that's VLAN. Okay, so let's quickly check about what IP assigned to this and it's able to ping himself. That is IP config window piece. I can see default gateway is 192.1.11 is pushed. So this is one IP which is assigned now. So I can pull the IP without any configuration because already in default one is on in this network. This where we can see that. So we have DHCP and let's take the P automatic going to take IP from. We're going to first understand what is the forward map and how it's different from the filtering. How the switch going to decide which one supposed to forward and which MAC supposed. So for filtration lab, I'm going to add one hub from the network. So I'm going to select this and I can see there is a hub. So I'm going to select one of the hub that placed over here. I will move and configure a little bit up. I will bring my hub right side. I will add couple of pieces to the test. I'm going to add for the hub laptop 0 and laptop 1 going to be connected. This is the laptop 1 and 2 and I'm going to connect this from the connectivity control action. Going to select multiple. This is the laptop, these two laptop connected with them. So let's see how it's going to the IP from DHCP. Already studied about. Today we're going to just assign IP from. I have assigned the success in 192.168.1.1. That is default one. That not. This is wrong. Let me select DHCP. What happened wrong with this? If you go to service, the switch on the service is 50. Let me from 1 do save again. This is change now. Now I have to try again. It's supposed 21. Yes, now it's getting 20. It's working fine. So we have PC assigned from 21. So I'm going to assign all these 4 PC. You can see the connected with the switch to the DHCP, the IP from DHCP. got IP 1.22. Next, we're going to assign laptop 0, which is connected to the hub. That's also successfully getting the IP assigned to .1.23. And the next we have Dhcp 4. So all the PC, I got the IP assigned as 192.168.21.20.23.20. Now I will check what are the Mac population because these 4 PC getting the IP from DSC. So how they are getting the ARP request going through the switch 2, switch 1, and then DHCP. They understand they need the IP, and they again going to since the ARP going to flood it out. They got the ARP in. So those source or MAC destination MAC they enter in this according to that. So according to the source MAC address populated the MAC. So let's see. Before that, I'm going to give the host name as the same switch 2 so that there is no confusion at all. Let's go switch 2. We are on the console of the CLI of the switch 2, and we're going to check the MAC address. So MAC address table, and I can see that I have learned the MAC address. There is a connectivity the ports each and every for MAC. Let's quickly brief that what are the MAC address and on each and every port how many MAC address. So first MAC address which is learned on fast Ethernet 0/2, that is nothing. You can see this is the fast. You can see dragging it down. This will fast connected to PC3. So we have MAC address associated with the PC3. So this is the PC3 MAC address. PC3 MAC address ending with the E25. Let's cross check. E2. Alright, let's do IP config, and we have MAC address E5. We are good. Now we have fast Ethernet, and I did not see any other IP, any other frame or MAC address accumulated on. So only one PC is connected, one MAC address. If I'm looking for fast Ethernet 0/4, I can see there is 2 MAC address learn. This is connected with the hub, so it's expected to more than one MAC address could be learned. So it's connected to the hub, and we learn the two MAC address. One is 576 and another is 6E0C. Let's quickly check. So I'm going to go to the laptop 0 that's connected to the hub 0, and we will check the that is IP config. So I can see that laptop 0 having 6E0C laptop, and laptop 1 we have IP config that is a MAC address 5768. So you can verify 5768 is my laptop 1, whereas 6E0C is my laptop 0. So we are running both the MAC address on the fast Ethernet 0/4. Okay, and I can see fast 001 having two MAC address, that is your 8596 and another is 7B02. That maybe we receive the DHCP. Quickly verify, then we will move to the lab. What we have to understand forwarding, so go for DHCP, sorry, go for config desktop. Now you can go for, I can 859C is your DHCP MAC, and that the switch having same for the having 8596 and 59 switch have 5 and another one more. Apart from that, they all the MAC address learn. So there is a PC3 MAC address, PC4 MAC address. There is a MAC address related to the laptop 1, laptop 0, and the other is. So we have MAC table populated. There is a MAC table. Now this is due to aging time. They flush the MAC table from the MAC table going to plus the MAC address from the table due to the aging. So we're going to not going to consider today aging, just we have this. So we're going to ping again and we will see how it's going to reach to the DHCP. First we have this, I'm going to ping my DHCP 192.168.1.11. so you can see there is a packet moving to the laptop to hub and it came to the my switch. How are we going to see that? Let's see the MAC. You can see there is an entry came, one of the entry, that is 8596 from the uplink fast ethernet 0/1. This is the DHCP MAC address which is running this entry going to. So we have this entry on the interface. So once the packet coming from laptop 1, they will do the forwarding, because for source and destination is the map to the 01. Source is 04. Let's do the packet simulation and we're going to understand. So I'm going to ping this 11 and we will start the simulation and we going to capture what. So they reach to hub before and the switch. Now let's see. They found that the packet coming on fast ethernet 04 interface with the source MAC, this destination MAC belong to the DHCP, and on the forwarding table, means in MAC table, they have registry of the MAC address associated with the fast ethernet 01. So if the destination MAC address belong to different port than the source received on the port, that comes under the forward. They will forward they will receive the frame on one interface, that is 04. They will forward to the new interface fast ethernet 01. So this process, the source and destination port is different, so it will come under the forwarding. They will take action, we can see. But in filtration, it's going to be same port, your source and destination on the same port, so it's going to be smartly not going to broadcast, it's going to filter, they ignore that packet. Let's see that. So I'm going to stop this simulation. Let's understand we have hub connectivity on the port pass Ethernet 0/4, and we have two MAC address 5768, that's the laptop one, and another laptop connected 6E0C on the same port. You can see these two port, these two different MAC on the same port. In this case, filtration going to up. If any of this source and destination, if these are the source and this is the destination, or this is the source and this MAC is destination, so it's going to be filtered because they are belong to same interface, so there is no forwarding. Let's see on the packet level, is it truly. So I'm going to start simulation for him, and the laptop 0 going to send the ping packet to laptop 24, that's the laptop 1, the IP is 192.168.1.24, 192.168.1.24. Now simulation going to start here. You can see the packet is starting from the laptop, and you can see that packet, what have received the packet received on it, going to send to every outgoing interface. So it's reached to the switch 1. I'm interesting once it will switch 1, that I need to check, where is the switch 1. So laptop 0 and the switch 2, sorry, that's I need to. So this packet, you can see that there is no layer 1 entry there. On layer 2, if you see in layer packet, this is the in layer packet, and the source is laptop 0. We are looking on the switch device at switch 2. The destination is 1.24. You can see it's received the packet over here. It's checked the source belong to the pass Ethernet 4, that's right, because the packet coming on the pass Ethernet 0/4. But it's look that the destination also belong to the my pass Ethernet 0/4 interface. So what they do for outer layer, they did not do any action, they did not assign any layer 1 forwarding port, because this is the filtration, there is no forward. So this way switching to the smart filter. I hope the forward and filtration concept is clear. I'm going to stop this. So for forwarding we have outer layer, different of that. For filtration there is no assignment for the forwarding ports, that's the smart filter. So we're going to switch the next topic. We have, if you have any question, you can post me on that. Now we are looking for the native VLAN and default behavior of. So let's quickly, we will check it out on that. So I'm going to start from switch 1. So before starting, I'm going to configure the switch 1 as a host name 1. I'm going to save, and then I'm switching on. I'm going to open the console of the switch. Now on the console of the switch, first command, I will check my MAC table. MAC address table, and I can see there is a multiple entry. So this is the layer 2 entry we have. For the layer 3, that's a VLAN, we have layer 3 VLAN, layer 2 VLAN. So we're going to discuss today, because this is a layer 2 switch, the entire infrastructure connectivity with the layer 2 only. So my command for VLAN to check verify the VLAN, show VLAN. Show VLAN shows that what are the VLAN do we have by default inbuilt in the switch. So we have VLAN1 that is belong to the name that is called default VLAN. What is the status? Status is active, and by default all the port associated with this switch are belong to inbuilt VLAN that is called VLAN1. Now you can, as soon as you can create new VLAN and assign to that, it will, this interface going to move and associated with the new VLAN. However, for switch, for the layer 2 switches, this is a default behavior we can create at a time. We can make the active VLAN 3 only one, that is called management purpose. So here we have only one VLAN right now, that is a default VLAN. So the default VLAN and management VLAN going to be same. How do I check? So I have command show IP interface brief. So IP interface brief give you the VLAN1. If you see bottom of the output, which is I highlighted just now, you can see on your screen VLAN1 unassigned, the status active, okay, yes, and it's a manual administratively down state. We will discuss later on. This is only one VLAN default running, but you can configure another VLAN and you can assign management VLAN any arbitrary or integer value VLAN to that. Okay, so we can create, we have default VLAN and native VLAN same by default, which is going to use for the management interface. And you can assign for management purpose IP in that area. So let's assign the IP and verify. So configure T, I'm going to assign the interface VLAN1 as a management IP. I have gateway 192.168.1.1. I'm going to take the same range, assign IP for the switch. So switch 0, 1 and 2 switch. So I'm going to take the IP 240 switch, switch 143, and then switch 244. So let's configure this IP address, and my IP will be 192.168.1 is default gateway, 2 for the switch 0, whereas 3 for the switch 1. So I'm going to assign this IP /24 subnet mask. The no sir. So you can see as soon as I hit, it came up because VLAN 1 is up and all the interface L2 interface are associated 1. Should I able to ping to any of the assigned with the same name? Yes. 192.168.1.11 we have Dhcp in our network after dropping back. Now let's ping to from any switch or any PC to this desktop from this switch. So I'm going to use my laptop 0, which already done earlier for pinging of others. So this my DHCP, that's a pingable. Now come to, I'm going to check my switch configure with IP dot. Couple of packet may be going to drop. You can see packet timeout, but from second packet it's a stable. So you can see the default VLAN, there is a provisioning of VLAN by which we can configure the management VLAN as a management VLAN to the net. So I can change this management VLAN from the native any other VLAN. Okay. We will see in upcoming classes how to configure different VLAN as management and native VLAN also different. We will see that in upcoming section of this. Okay, now this is the one part. Second part, we are looking what is the default spanning tree, because here only the single connectivity we have, so there is no loop going to be occur. Even though there is a default default spanning tree is running, this is the default behavior of the. So let's check it, what is the default behavior, default spanning tree, and what are the attribute do we have. So later we will understand each and every attribute and we will do dedicated lab for. So we have command will be show a spanning tree, just show a spanning tree you give. This is a big command and we'll try to understand what are the default attributes installed here with the VLAN. So we have VLAN1 means the spanning tree instant going to run for every VLAN. If we have 10 VLAN, we have 10 spanning tree instance by default. I'm talking about today only the default behavior. So this is understood. Whatsoever I'm speaking today, this is only related to the default behavior of the. Now we have default is going to be IEEE, that's an open standard one. Okay, and we have root ID priority. We will going to study what do you mean by priority and how these numbers going to be calculated and what is the role of them. So you can see there is a default priority value going to take 32769. This is the default priority. We can decrease or we can increase. Then you can see address. This is the VLAN management address. If you see, this is not belong to port. So how do you get this MAC address? That is from show version. If you see this MAC address coming from your churches, the base Ethernet MAC address, that is 5180 ending, and it's starting from 0017. So this is not the same MAC address which is you receive on the churches. You can say this is the different. Then which MAC address it's allocated to this? Which MAC address? That's a question mark. And another MAC address you can see bridge ID. So we're going to see this is not a church's MAC address. So which MAC address this? You can see there is another MAC address for the bridge ID. This is for root ID. This is the bridge ID. Bridge ID belong to your local system, and root ID in VLAN1 who is selected root So you are not a root here if you have different MAC address from your root. So you can see this MAC address is belong to you, and the MAC address used from churches, that is 001759A75180. So you can see here the bridge ID 00D0FF46CB89. So you can see the MAC address of this is also different. So you can see interface VLAN1 and the MAC address assigned to your, this is the MAC address which is the VLAN1 dedicated assigned. This is different from the churches base MAC address, and this is going to be part of your bridge ID, that is nothing CB89, which the bridge ID CV, and your priority going to be added to the default one plus one. This plus one is nothing because your VLAN1, so it's going to add to your default priority. That's become 68 plus 1 T2769. So you can see. So we will going to see later on the value of VLAN as a system extended ID going to be on adding into your priority, and it's going to make the unique priority for the specific. So this is the default behavior. You can see we have default costing 90 because the fast Ethernet is depend upon the Ethernet or the connectivity bandwidth. Then which port, the default timer values, we're going to study the detail about the timers. What are the timers? So for that you can understand today, we're going to see only today. And make a note, there is something called hello timer which having 2-second, max age timer 20-second, and forward delay we have 6. And we're going to the detail lab for this or the time. So however, for you can briefly understand this hello timer is nothing, is a BPD change. So what is BPD in detail we will we're going to understand in upcoming classes about this topic. So this is the default behavior. You can see we are running with the instant, and they have root bridge selection, they have designated port, and the cost associated with the priority, with the port priority. So we're going to understand each and every topic, like what is the port priority, how they going to declare that, what is the forwarding designated for root designated and forward in the detailing. So you can understand the spanning tree is by default running. They do all the calculation of the spanning tree. So who is the root? What is the next command to understand? So a spanning tree, you can see the other option do we have. What are the active? What are the summary VLAN? And the detail you also can see. Let's see the summary of the VLAN spanning tree. So we have summary of a spanning tree that's showing that all the ports are on forwarding, and these are the enables. By default switch in PVST mode. We're going to study what are the mode. That is, come to BTP protocol. What is the protocol running by default? Other protocol. So we have the Cisco proprietary protocol that is called VLAN Trunking Protocol. But the spanning tree protocol is not a Cisco proprietary. This is an open standard protocol, and you can find this protocol running in the all the vendor across the technology. Now, so BTP, what is the default behavior VLAN trunking protocol? The command is so BTP status, and we will study the default attribute config regarding the BTP protocol. So we have capable of BTP 1 and 2 version, but it's by default running with the BTP version. And the other things you can see the Cisco device ID, other parameter like it's a disable, BTP pruning is disabled, BTP trap generation is disabled, and but the features VLAN feature which is associated by default BTP mode will be server, and the number of existing VLAN is 5. Okay, and the MD5 digest we will do the lab and we will see how it's going by the revision. So we have to remember a few things by default. So we have configured revision number 0 and the BTP mode will be the by default. And there is no BTP domain name. The BTP domain name is null. So 3 point you should understand, sorry, you have to remember 4 point. By default it is going to generate, that's a BTP version running with the version 2. There is no BTP domain name, that's null, and they have BTP operating mode as a server, and there is a configuration division number will be 0. So you have to remember this all the attribute. We will going to see you in next class. You can post your query. We will going to describe more. So we're going to continue the next class from the point we're going to start the spanning tree protocol, and we understand what are these feature and attribute, and we will do respective lab. So see you in next class. Bye bye.